Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it. Picture this. Exam room, paper in front of you, 8 marks on a routine question. You write 3.4 as your answer and hand the paper back. Later you discover you lost full marks. Why? Because 3.4 wasn't exact. What range does 3.4 to 2SF actually mean? And how should you use that range in calculations? Stay with us. This episode gives you the exact habit that stops those almost right answers losing marks. Right away, the difference is this. A rounded number stands for a whole set of possible exact values. When a question says to 2 significant figures or to 1 decimal place, you must convert that instruction into an upper and a lower bound before you do anything else. Treating the rounded figure as exact is the single most common mistake on these questions. Let's make this concrete. Start with to 1 decimal place. If a number is 3.4 to 1 dp, that means any number from 3.35 up to but not including 3.45. We often write that as 3.35 smaller than or equal to x smaller than 3.45. Why? Because 3.35 rounds up to 3.4 and 3.45 would round up to 3.5, so it's excluded. Simple language. The lower edge is halfway to the previous representable value, the upper edge is halfway to the next one. Now to 2 significant figures. Take 3.4 to 2SF, the same interval, 3.35 smaller than or equal to x smaller than 3.45. For numbers like 350 rounded to the nearest 10, the phrase to the nearest 10 means 345 smaller than or equal to x smaller than 355.
Another quick rule. For to n decimal places, increase or decrease by half a unit in the last place. For to NSF, think in terms of significant digits and place value the same way. Write the bounds down. That's the first habit. Example 1. The exam might give you 1.2 to 2SF and 3.4 to 2SF and ask for the product. Convert both. 1.2 to 2SF means 1.15 less than or equal to A less than or equal to 1.25. 3.4 to 2SF means 3.35 less than or equal to B less than or equal to 3.45. Now, for multiplication, we pick extreme values to find the smallest and largest possible product, because the exact values could be anywhere in those intervals. Do the checks quickly. Multiply the 4 corner combinations for positives. Lower times lower, lower times upper, upper times lower, upper times upper. For our numbers, we get roughly 3.35 times 1.15 about 3.85 and 3.45 times 1.25 about 4.31. So the product lies in about 3.8525 less than or equal to product less than or equal to 4.3125. Write that down. Examiners want to see the interval, not just a rounded midpoint. A quick note about signs and zero. The corner method assumes positive ranges. If a range crosses 0 or includes negatives, you must test which combination gives the minimum and maximum. That might be lower times upper or other combinations. If in doubt, the safe method is to calculate all 4 products and pick the smallest and largest. For addition or subtraction, it's easier. If x is in xl xu and y is in yl yu, then x plus y is in xl plus yl xu plus yu, and x minus y is in xl minus yu xu minus yl. Always add the lower bounds to get the lower total and add the upper bounds to get the upper total. For subtraction, swap the upper and lower appropriately. Write it out so the examiner can follow your logic. Let's pause and summarize the method in 3 short rules. 1. Convert the wording into lower and upper bounds and write the inequalities. 2. For plus and minus, use direct combination of bounds. 3. For x, division and powers, use the corner method. Test extremes and state the result as an interval. Let that sink in. Short pause. The exam technique. Here's what markers look for. Most bound questions are split across method and accuracy marks. A typical scheme. M1 for stating the correct inequalities or bounds. M1 for showing the method using those bounds, for example demonstrating lower times lower and upper times upper, or the 4 corner products. And A1 for the final interval or value given with the correct inequality signs. So you can lose marks by skipping any of those steps. common pitfalls to avoid, giving only a single number instead of an interval, using the midpoint of the interval as proof, that doesn't show extremes, not carrying the exclusivity or inclusivity of bounds, write less than or equal to or less than where appropriate, and importantly, even if you can't finish, write your inequalities and one bound calculation. That often wins you an M1. Mark schemes also like to see the reason. A line like 3.4 to 2SF returns 3.35 less than or equal to x less than or equal to 3.45, followed by 1.2 to 2SF returns 1.15 less than or equal to y less than or equal to 1.25, and then a clear multiplication of extremes is gold. Box your final interval. The examiner sees your thought process immediately, and that's what earns method marks.
James Carter. The quick win, your 30-second exam routine. Do this every time. 1. Read the rounding instruction and copy it at the top of your working. 2. Write the lower and upper bounds clearly as inequalities. 3. Show one line of method using those bounds. For multiplication, show at least lower times lower and upper times upper or the corner products. 4. Box the final interval and add a short note, bounds from rounding, so the examiner knows you did it intentionally. We'll demonstrate in 60 seconds. Question. Calculate 4.2 to 2 significant figures times 3.1 to 2 significant figures. Step 1. 4.2 promotes 4.15 smaller than or equal to a smaller than or equal to 4.25. 3.1 promotes 3.05 smaller than or equal to b smaller than or equal to 3.15. Step 2. Compute corner products. 4.15 times 3.05 approximately 12.6575 and 4.25 times 3.15 approximately 13.3875. So answer 12.6575 smaller than or equal to product smaller than or equal to 13.3875. Box it. Quick, clear, method mark guaranteed if done neatly. That's a practice you can do tonight. Take 5 mixed rounding items from a past paper, convert to bounds, and push them through a calculation. Time yourself for 2 minutes each. You'll start to spot the patterns very quickly. Teacher and parent note. For teachers, create single-topic past paper packs that only test bounds for 10 minutes at the start of a lesson. Then peer mark with the mark scheme prompts, M1 bound stated and A1 interval given. For parents, you don't need to reteach the algebra. Ask your child to show the lower and upper bounds and one method line. Ask them why they chose those extremes. If they can explain it aloud, they're secure. A short practice idea for parents at home. Give 3 rounded numbers on a sticky note and ask your child to produce the 3 intervals in 1 minute. Then pick one calculation and do the corner check together. That 15-minute routine, 3 times a week, beats a single long session once a month. CTA. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more work solutions and a free downloadable worksheet of bounds examples, plus the printable 30-second exam checklist at jcacademyonline.co.uk. Visit the website to get the worksheet and the checklist you can stick in your exam folder. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more work solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.
Focuses on exam technique and clarity for GCSE students, parents and teachers.